All right, I think I've got that going correctly. All right, I am calling this section 1-3B. We're still talking about inequalities. Now it's compound. There are two types of compound inequalities. We call them ands and ors. One of them has an and in it, one of them has an or in it. So I'm going to start off with the ands. We'll talk about those for a bit, and then we'll go back and talk about the ors. So all right, and inequalities. Have solutions that work for both single inequalities. There are two ways to tell that you have an and inequality. One of them is that they literally use the word and. So I'm going to start with that because that one's very obvious. If it says and, it's got to be an and. And then we'll talk about the other way that they could be represented. So let's say, for example, I asked you for, let's say I said solve this. Let's say x plus 3 is less than 10 and let's do x plus 1 is greater than 2. So if you're given something like this, it's clearly an and inequality because we have the word and. All I'm going to do is I'm going to solve each single inequality like I normally would. So I start off pretty easily. And so on the first one, I would just subtract 3, right? No big deal. Minus 3, minus 3. So x has to be less than 7. I'm going to bring down the word and. Here, I'm just going to minus 1, minus 1. X has to be greater than 1. So here's where things take a little bit of a turn. My final solution has to satisfy both of these at the same time. So I need a number that's not just less than 7. It has to also be greater than 1 at the same time. So can you give me an example of a number that does that? 2, 3, sure. Anything in between 1 and 7, basically, right? So even 6.5 would work. Would 7 itself work? No, because if I had the bar underneath, then sure, but I don't. I need a number that's less than 7 and greater than 1 at the same time. Okay? So when I go to graph a final solution like this, so what you can do, and I mean, eventually you become so good at it, you don't even really need to think about it, but sometimes we throw curveballs at you. So here's what you're looking at when you're going to graph. So let's say graphing the solution. Of an and inequality. First, you're just going to graph each one separately. I mean, and again, you don't always do, sometimes I just do it in my head, right? But right now I'll show it to you drawn out. Graph each solution separately. So my first one, if I just make a little number line here, my first one was x is less than 7. So let's say I put 7 right here. Use some different colors. Purple. I have it opened out at 7, and I'm going to shade to the left, right? So I want all the x's less than 7. I'm going to grab x is greater than 1. So far, so good. I just grabbed each one separately. Now I need to consider where these two graphs, if I were to overlap them, where do they actually overlap, or where do those two answers intersect each other? And that's going to be my final answer for an and inequality. So now I'm going to say graph only where the two graphs intersect or overlap. So I'll put both of my important numbers on it, 1 and 7. Okay, so do they both overlap at 0? No, so I'm not going to put them there. So starting at 1, I don't actually have a value at 1, so I'm just going to bring down that open circle, get another new color. But see how they both overlap everywhere in between 1 and 7? I guess I'll add 7 to this. There's a 7, there's a 1. Okay, everywhere in between 1 and 7, we do overlap, so I'm going to have a line there. And then at 7 itself, they're not both there, so I need to sort of cap it off with that open dot. So that is our solution to x is less than 7 and x is greater than 1. When you give an answer, it's crucial that you use the word and, or if it's an or, you would use the word or. You can't just write both of those without the word in between. Then we don't know, is it an and or an or? Because they're completely different. So make sure if it's an and, you're saying that it's an and. If it's an or, you say that's an or. So far, so good? Oh, yes, go ahead.
Instead of using and, could you use the union symbol for the steps?
Sure, why not? There is another way to write ands that doesn't use the word at all. And that sort of joins them all in one. So let's look at a problem where that is the case. So let's do, let's see. Another way to write an and. Another way ands are represented. Let's do that. Oh, let's do something like -10 less than 2x, which is going to be less than 6. Something like that. If you ever see an inequality that's written like this, and it doesn't have the word and or in it, that's an and. Ors can never, ever, ever be written like this. So any inequality that you ever see written like that is automatically an and. If I want to solve this, my goal is still the same. I still want to get the x by itself. So you have some options here. You could rewrite this as two separate single inequalities. I usually don't, if I'm honest with you. I just kind of treat it like an inequality that just has 3 parts. So instead of having a left-hand side and right-hand side, I have a left, a middle, and a right. So I do the same thing that I normally would do. How would I normally get this x by itself? How do you get rid of that 2? Divide. Exactly. I just need to divide everybody by 2. So I'm going to divide the middle by 2. I'm going to divide the left by 2 and the right by 2. So I just get a -5. I've got the x in the middle. I got the 3 over there. I like these way more because it's so much easier to just see it already put together. I don't have to think about who's overlapping here, there, where. I do need to make sure that this answer makes sense. Okay, because let me show you, don't write this down, but let me just show you an example. Let's pretend you had tried to solve something and your answer came out like this. I don't know. How about just if I did 5, don't write this down. 5 is, what if I had this? This makes no sense. Because if you look at each one kind of individually, that says that x is a number that's greater than 5, but it's less than 3 at the same time. Can you give me a number that's greater than 5 and less than 3 at the same time? No, this has no business existing because it doesn't make any sense. Sorry, but not today. Okay? So you do need to make sure that your answer is actually valid. But I do have numbers that are, if I look at them one at a time, greater than -5 and less than 3 at the same time. I could give you an example of them. Give me one. Give me a number that would work over here. 1, sure. There are numbers that exist that do both. So I know that this is a valid answer. And if I wanted to graph this, yes, you could take the time to graph each one separately, but especially when it's written like this, you could just jump right to your answer, right? If I have a -5 and I have a 3, put the 0 in the middle if you want. What kind of a dot am I going to have at -5? What kind of a dot? It's going to go right there. Open. What kind of a dot at 3? Open. And I want all the numbers in between, right? Isn't that what this is saying? Numbers that are greater than -5 and less than 3 at the same time. There they are. Done. Now be careful when you have one that's written like this, especially if you're not going to take the time to split it up. If you do divide by a negative, you flip both signs over, right? That stays in place. So all the same rules apply. So just make sure that your final answer is valid, makes sense, because you can have no solution to certain and inequalities. You can? Yeah, should we try one? Okay. Good idea. I sort of let the cat out of the bag, but so let me make one up. So how about, I'll do one that's separate. How about x plus 3 is less than -2 and 2x is greater than 10. So this is an and type where it's not all joined together. We have it as 2 separates. So I'm just going to solve each one separately. But I need to remember that for these and inequalities, my answer has to work for both sides. So can you give me a number that's less than -5 and greater than +5 at the same time?
Oh, wait, no.
Yeah, I agree.
Okay.
Yeah,
I have to
there,
think about it for a second.
there isn't one that exists. So I already know that there's no answer. But sometimes you kind of get lost in this. If you try and graph this, right? If I actually take the time, all right, let me graph them. I'll do them all on the same line. That might be helpful. So here's a +5, here's a -5. So if I'm going to graph this one, I would want the numbers that are less than -5. That would be those. And I want the numbers that are greater than, let me switch colors, greater than +5. If you remember, from just a moment ago, we said that when you graph the solution, so these are just each of them graphed separately. So my actual answer has to be where these two overlap. Where's that? They don't. These never overlap each other, so this has no solution. If this is an and inequality, which it is, there's nothing I can do with this. So that's not the answer, right? Those are them separately. So I'm going to say this and inequality has no solution. There are no numbers that are both less than -5 and greater than 5 at the same time. So if this were a test or a quiz and I gave you an answer line, you wouldn't put any of this down. You would just literally write no solution because there's nothing that works here. I understand that you could graph each of these separately, but my final answer has to be where they overlap, and they don't overlap, so there is no solution. Does that make sense? Oh, good. All right, let me give you just a couple to try before we move on to the ors. Oh, silly me. I don't think I ever. Let's go make it up. Darn it. All right. Wait, that's why. Emojis. Oh my gosh. I remember making this thing years ago. And I was just thinking this morning, oh, I wonder if I still have them. Here they are. Let's see if these would, maybe we could do these later. Maybe this would be a good thing for Monday. Anyway. Here we go. How about we try, all right, that one's pretty good. All right, try to solve and graph that one. I'll give you two. So there's the first one, and then the second one I'll put over here. Okay, how'd we do? All right, let's look at the first one. So this is one of those ones that's joined, it's written all together. All right, so I want to get that x by itself, so what should I do? Jay, go ahead. Yeah, I'm doing x minus 8, so I want to add 8, but I got to add 8 to everybody. So the left, the right, and the middle. Okay, do I have to flip signs right now? Am I flipping? No, I didn't multiply or divide by a negative. Right, if I'm just adding or subtracting, I don't change anything. So what's that going to be? A -3. And then I get a 0 over here. Don't panic when you get zeros. 0 is a number like anybody else. You just treat it like it's any other number. So now I ask myself if this answer even makes sense. Are there numbers that do both, that are greater than -3, that are also less than 0? Can you give me an example of one? Sure, -1. There are numbers that satisfy this. So I know that this is a legitimate answer. And then if I'm going to graph it, these, in my opinion, are a little bit easier to graph. I got the -3, I got the 0. It just so happens we're going to have open at both. These could be closed, right? If they had a bar underneath, but they don't. So there it is. And remember, when you are shading, when you make this bar, right, or however you're indicating where your solution is, everything you're drawing that bar or you're shading over is an answer. So yes, -1 is in there, -2 is in there. So you should be able to take any number and plug it back into the original and it should still work. Okay. All right, now number 2 is set up, it's already as 2 separate things. So I'm just going to solve each one separately and we'll go from there. Okay, first one, we're just going to multiply both sides by 2, right? Multiply you by 2, multiply you by 2. Should I have flipped the sign over there? No, doesn't matter that that's a negative number, who cares? It matters what I'm multiplying both sides by, and that was a +2. I'm not going to touch it at all. And I bring the word and down, and this one I just -2 minus 2. X is going to be greater than or equal to -3. All right, so now I have to stop and think about this. All right, I need a number that's less than -2 and greater than, or less than or equal to, and greater than or equal to -3. All right, so what I can do is I can try and graph both parts, and then my final graph, my actual answer will just be where they overlap. So let's see, 0, -2, -3. All right, so here, I put these in different colors. I want the numbers that are less than or equal to -2. Open or closed? Closed. Less than or equal to -2 is that. And then this one, greater than or equal to -3. So I'll have this. Greater than or equal to -3. And then my answer, my final answer is supposed to be where these overlap. So I'll draw a fresh one. So would I put anything over here? No, because they don't both overlap right there. Do they both overlap at -3? Yes. Let me get a new color. How about green? Never shows up. Green's my favorite, but it doesn't show up. I'll try this pink color. Tell that it's different? Not really. Bummer. It overlaps all the way in between -3 and -2, and it overlaps at 2 itself. Does it overlap over here? No. So this is my final answer. And that is x is less than or equal to -2, and x is greater than or equal to -3. That makes sense? All right. Let me give you a curveball. What happens when you have something like this. So third example, let's do, oh, how about x plus 2 is less than 10 and x plus 5 is less than, I don't know, 6, whatever. Try that one. All right, yes. What's so fast? What happened with this one? Adam.
Yes. So this particular graphic is like everything less than one. Because that's when they start like overlap.
Exactly. So this one's weird. I'm gonna start off the same way. I'm gonna solve it like I always do. Minus the 2, and minus 5, x is less than 1. So if we stop and think about this, before I even look at the graphs, I need a number that's less than 8 and less than 1. Give me an example of a number that does both of those things. 0, sure, right? Could I say something like 6? No, because it doesn't work for both. So if I look at the graphs, so let me just get myself set up here. I have 1, oh, whoops, make that name. All right, so one of them, the x is less than 8. I'll do that one in purple. If I'm looking at x is less than 8, it does that. And then x is less than 1, looks like that. So for my final answer, I need where it overlaps. It's not auto. Very often kids just automatically make a bar between the two numbers. Most of the time, yeah, that's what happens, but not in this case. It's not the numbers in between 1 and 8 at all. The numbers that do both of these things are just all of the numbers that happen to be less than 1. So my final answer, where they actually overlap, it's only going to be here. Bring down this. That's my final answer. So if I were to write like, so there it is graphed, but my final answer, it would not even be both of these. Because if a number is going to be less than 8 and less than 1, from that, my answer is really just x is less than 1. Does that make sense? Yeah, can be tricky. So always be thinking, I need something that works for both of these. If only one of them is the one that ends up working for both, then great, then that's my final answer. I'm just gonna throw one more and in that has like weird stuff, like some fractions or something. So I gotta flip the page, sorry. Oh, I do have a blank page. I didn't think I did. Lucky me. And then we'll switch over to the ors. Oh, let's do. Oh, that one's kind of cool. All right, let's try this one. So if I'm gonna try and solve something like this, I want to clear the fractions, just like I normally would. Okay, so I'm gonna start off that same way. What's my magic number gonna be that I multiply everybody by? 70 in this case. I just have to make sure I'm doing it to all parts. So divide down, multiply up, that's gonna get me 30. 30x and 39. All right, and then I would just math. You got it. I'm still always trying to get that x by itself. So now I just have to divide everybody by 30. And let's see where that gets me. 1x 39 over 30 is 1 point something. I'm gonna want it at, what is it? Oh, thanks. I want it as a decimal because if I'm gonna try and graph it, a fraction doesn't really do me much good. Okay, well, before we go on, are there numbers that do this? That are bigger than 1 and less than 1.3?
Yeah.
Can you give me one? Sure, 1.2, 1.1, any of the ones in there. So I know that this is a valid answer. And luckily it will be pretty easy to graph. So here's a 1, here's a 1.3. And I'm just gonna have a bar in between. Thoughts? We're okay there? All right. Oh, thank you so much. No problem. Have a good weekend.
School tomorrow.
All right, let's talk about ors quickly and then we'll be done. Okay, so or inequalities. These cannot be joined together like we saw the and. So ands, remember, there's two ways. Either it's literally going to say the word and, or it's going to be written as one big giant compound one with 3 parts. Ors can't do that. Okay, ors have to have the word or. And I'm sure you have figured out the difference. For ands, I needed a solution that works for both. For ors, I only need a solution that works for one of the 2 options. Okay, so only one piece needs to be true. So for example, if you want to go to the movies this weekend and your mom says you need to either do the laundry or do the dishes, or she says, right, do the laundry or do the dishes. You only have to do one, right? Right? You get the pick. Do you want to do the laundry or do you want to do the dishes? If you do both, can you still go to the movies? I bet you can. I bet you she's going to give you money for popcorn too. But that's the difference. Or you only have to satisfy one of the 2. You don't have to do both. If it does both, okay, great. If you do none, can you go to the movies? Of course not. So I have to satisfy one of the 2 conditions. Satisfying both, that's just a bonus. Okay? All righty. So let's try. I'm going to start it off the same way. I'll pick an example from here. Oh, that's a good one. X plus 5 less than or equal to -1, or X minus 10 greater than or equal to -14. So I'm going to start off by solving each separately, just like I normally would. Easy peasy. Add the 10, add the 10. Now, when I consider the graph of my solution, this one, I'm just going to combine both graphs. That's it. So if I graph my first one, I'm gonna do it on the same set. So let's see, we'd have a -4 and a -6 here. So if I graph x is less than or equal to -6. There's that one. If I graph x is greater than or equal to -4. There's that one. That's my answer. I don't have to worry about them overlapping. It is possible that they overlap. So I'll show very, 80% of the time, the ors just go in opposite directions of each other. I'll do an example where that doesn't happen, but that's my answer. I just take the two and I combine them. So my, let's see, graph of the solution is just both graphs combined. I don't want to think combined like overlapping like the last one was. I'll say both graphs drawn on same number line. So that's it. That's my final answer. All of this right here. So there it is written as an inequality, and there it is graphed. Final answer. All right, let me show you one where they do overlap each other. I'm just gonna make it up. Let's do, how about x -3 is less than or equal to 10, or x, well, let's do 2x is less than or equal to 6. Yes.
If we write answers,
Do I prefer, say it again, set or what?
set builder notation.
Round roll one over here.
I don't care either way, to be honest. Whatever you want to give me, as long as it's right, I'm happy with it. Add 3, da, 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 da. Divide by 2, divide by 2. La, 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 la. Okay, so we got those two? All right, now let's look at the graphs here. All right, so I'm gonna graph my first one. Let me put a 0 there. Here's a 3, here's a 13. Okay, cool. So the first one has x is less than or equal to 13. So I'd have a solid going this way. There's that one. This one, x is less than or equal to 3. Now, these are both going the same way. Right? Do you see this? So if I were to just draw these like squashed together, wouldn't it just create this graph? Doesn't that just make this? If I literally just squish them down, here's 0, here's 3, here's 13, doesn't it just turn into this? If I just literally imagine squishing them together. That's both of them drawn together. It just so happens that this purple one is overrunning the red. It doesn't matter. If I said, hey, give me a number that's less than 13 or a number that's less than 3, couldn't I have just said, give me another number that's less than 13? Right? I don't even need this piece. When it's ors, if I only have to satisfy one of them, couldn't I have just said anything less than 13, less than or equal to 13? Even if this had been an open dot, it doesn't matter because it would still have a solution right on the purple line. So it doesn't matter. Okay, so when I go to write the final answer, since these both overlap each other, I don't need to say both parts. I can just say x is less than or equal to 13. And this is my final answer. Does that make sense? It's a little weird when they overlap, but the important thing to remember, hey, if it's an or, I just need one of them to be satisfied. I don't, sure, if they overlap, great, bonus. You did the laundry and you did the dishes. Good for you. I appreciate it. Come to my house next. I'll pay you. But it only has to satisfy one of them. Okay? You feel all right? Yeah? All right. So let me give you some to try. And then that's it. Oh dear. All right, I'm thinking just odds again. 1, 2, 3, 4, 5. There you are. 1, 2, 3, and 4. 1, 2, 3. You're welcome. Yes. 4, 5, and 6. You are welcome. Okay, let me open this on Jupyter for you.